So I'm here to talk about distributed deep learning. So basically, doing deep learning over the Spark cluster. So I'm Vincent. I'm a data engineer. I've been playing with Scala, Akka, Spark for about 3 years now. And I mostly have a big interest in artificial intelligence and data analysis. So, just a small disclaimer, I'm not a scientist, I'm more on the engineer side. So I won't delve into more scientific matters, scientific topic today. But I try to explain what is deep learning, how it works, and how we can use it with Spark. So, deep learning, basically, it's based on machine learning. So most of you have heard about deep learning already. So it's based on artificial intelligence, and the goal is to create a computer that can do anything a human can do, maybe even better. So the ultimate goal is modeling the human brain. So to model a human brain, we will take the most basic unit in the brain. So scientists took neurons, and basically neurons get excited given a specific input, more or less excited. Something like that. If we want to model the neuron, we can model it like this. You have inputs, multiple inputs, could be images, could be pixels, could be anything. You have output, which is hypothesis. Is it a cat? And you have an activation function that say, well, if this function activates, then the hypothesis is true. So, for instance, the activation function will be the sum of all the inputs with some weight, depending on the input plus bias. So, for instance, if you have like the tail and ears and some eyes, well, maybe given the ears will be more important to define if it's a cat or not. So from a single neuron, we can build actually a network. So not one neuron, but many over many layers. So multiple inputs, multiple hidden layers, and one or multiple outputs. This one is called a feed-forward network because there's no loop between the neurons. So it goes only that way. No middle. And then we have some kind of neural network that are called convolutional neural networks. I don't know if you see, maybe not very well, but basically we have an input image, and from this image we are going to take little bits of every part of the image, and we are going to build feature map. So basically a layer of neurons with each feature, which is here. And then from this feature map, we can build another feature map, and then another feature map, again with small parts of the image. And those feature maps we will use to classify what is on the image. So let's see here, it's a face, it's a woman, then here it's a dog, and then here it can be it's very useful for image classification and image recognition. So for face recognition, for instance, we have an image as an input. We divide it in a lot of neurons, match parts of the image. And then from this, we get some basic lines, basic shapes. Then we put them together, we get like an eye, we get more specific feature. And then in the end, we try to identify which person it is, based on all those tiny little bits. Each layer is focused on a specific part, lines and shapes and space and classification. So what is it used for? Well, it's used for image recognition first, as we saw, but it can also be used with voice and audio recognition, sound. It can also be used with text recognition, text translation. You feed a big amount of text, and the neural network will try to learn. So yes, something I maybe didn't mention is the neural network learns by itself. It's kind of one of the interesting features. But the problem is, to train a model, it requires a lot of time. So let's say you have like thousands or 10,000 or 100,000 images. You need to divide the image. You need to. It takes a lot of time and a lot of computing power. So, for instance, AlphaGo used those kind of networks. Recently, I'm sure how many of you have heard of AlphaGo? Not everyone. Okay. AlphaGo is the intelligence. Is a program that is playing right now against the world champion of Go, and is winning two games to 0. So it's quite a big feat in artificial intelligence, because it's very difficult to compute all the possible position in the game of Go, and it has never been done. So it's done by DeepMind, a British startup acquired by Google, and it's the first time that top Go player get beaten. The European champion of Go lost 5-0. I don't know, 2 months ago, something like that. Yeah, about 2 months ago. So it's a very, very big step forward, deep learning and we could say machine intelligence. And so AlphaGo, for instance, required to train the model 1,202 CPU plus 176 GPU. So I don't know how many of you have this kind of computer at home? Not a lot, probably. So the problem is, how can we do this kind of computation? How can I analyze big data or some data that I want to predict, some images, some text, for a decent cost within a short time span? I don't want to spend like 2 weeks training a model. I want it to be fast, and I don't want to have my computer running in some space in my room doing the computation. So it's possible. It's possible on a single machine, but it will be very, very, very low, very long, and very slow. So the solution is to distribute this kind of computation over a cluster. Well, I'm at the Spark meetup. I imagine you figured that out already. So we can use Spark. We can use Spark to do this kind of deep learning, but distribute it over many nodes, compute the results, compute the model, and then talk to a master. But what can we use? What kind of cluster can we use? So who does that? Who does this kind of cluster, this kind of machine? Well, Amazon, AWS does that. They have nice GPU instances. Disclaimer, I don't work for AWS. I have no share in Amazon whatsoever. But they do have nice GPU instances. They have spot instances, which are we acquire on demand, and they are 2 to 3 times cheaper than regular instances. But the downside is it takes time to set up a cluster because it may not be available, and it's kind of auction. I don't know how many. Does someone have already used spot instances on AWS? Yeah. So yes, it's kind of an auction. So basically, you say, I want this kind of instance for this maximum price, and Amazon will try to find an instance that match. So basically, people who have already this kind of server and who don't use it, they can kind of lower the cost by putting them on spot instance. Sorry. No, it's not finished. It's not finished. It was a joke. So for instance, this kind of the bigger instance, this one, they have 4 NVIDIA GPU with like 1,500 CUDA cores and 4 gigabytes of video memory, 32 vCPUs plus memories and SSD for $1 per hour. And you can build a cluster with that. So basically, with that, you can really have at your fingertips a very huge amount of computation power. And you can, as spotted instance, you can shut the cluster down whenever you want. You will just be built by their own. Not bad. So, what are the deep learning frameworks that are used actually? Well, there are many, but main ones, there's Café from Berkeley, there's TensorFlow from Google, you have Torch, you have quite a new one, Leaf, written in Rust. And if you have a look at some benchmarks, well, you see the TensorFlow, I think it's 0.7, maybe it's not the last one, but it's quite a bit slower than Café, Torch, and Leaf. So basically, the whole idea of distributing computation over a Spark cluster can work with any machine learning framework. It can work with TensorFlow, it can work with Café. I don't know if they are binding for Torch or for Leaf already, but what you just need is bindings. So for TensorFlow, you have Python bindings. So if you use Python on Spark, bindings are direct. For Café, you need a wrapper because it's C. So you need a Scala wrapper on top of it, or Python wrapper. So some nice people wrote that. You have mostly 2. You have SparkNet from Berkeley, and a new one called Café and Spark from Yahoo engineers. They mostly do the same thing. Café and Spark is brand new, and well, it's used and maintained by Yahoo engineers. Well, the initial commit is from February 2016, so well, it's kind of getting edge. But it's based on the SparkNet wrapper, and if you're interested in that, I encourage you to read the paper. I put it in the resources. The paper from Berkeley, because they explain how they develop the wrapper, how it works, how it's splitting the computation between the master and the node, and it's quite easy to read for tech people. I encourage encourage you to read it. Yes, and yes, I'm doing Scala, so I was looking for a Scala wrapper. But yeah. So how it works? Basically, the computation runs over a Spark cluster. The master node holds the images and the model. So the image you want to predict and the whole model, the whole deep neural network. And the slaves, they run Café and they do the actual computation. And then they send back the result to the master, which merge all the results and then send back another unit. So the master has a model, broadcast the model, sends the weight. We use something called, the slave use something called gradient descent to converge, to match the result. So they do many iterations of gradient descent, and then they send back the gradient to the master, which merge everything, and then goes again in the same computation. So how to run it? You can run it on your local machine. You can run it on a cluster, on a Spark cluster, on an existing Spark cluster, or you can run it on EC2, which is what interests us tonight. And conveniently, there are ready-made images available for EC2. So that's perfect. You can make also your own image from the source. You can build the AWS image with all the dependencies, because you need to build Café, you need to build all the slave. Well, it's always good if someone says use yourself. So we try to do a small test on the MNIST dataset, which is a bunch of handwritten digits like this, and we will try to predict which digit is a 0, 1, 2, and so on. Well, it's kind of basic test. You will find this test in mostly every deep learning framework, as an introduction, and it's quite good introduction to understand what it's doing. So basically, what it does, and it's more clear, takes a digit as an input, gives a feature map with the first feature map, then the second one, the third one, and then with that, it does classification and tries to predict the kind of digit it is. So this step is called feature extraction, splitting all this into small bits, and this step is called classification. So I try to show you a demo. I try to set up the cluster and show you a basic classification. Well, please bear with me. I tried earlier, but I had problem connecting with SSH, so it's live demo. The output is is for each number you have the precision of the guess. So you have IDs, basically. Yeah. Let's go back on that. Basically, it will take each number with one ID, and it will try to say, for this number, I predict it's 0, and well, this is the accuracy of the prediction, and you can double check that it's really 0, that's the number. You can also do this with images, something like you take a photo and you can try to say, okay, what are the features of this image? For that, most of the time we use a pre-trained model as a base. Most of the models, well, one of the most common used models is called AlexNet. This is the one that you will find in most case for image classification, but you can then train it with new image.
And the training data, it's the image itself. Or
Yes. It's a whole bunch of digits like this. You have a train data and a test data set, and basically you train the model with the trained data set, and then you test it. You test the accuracy of the model with the other data sets. You may see it in the comments. Oh yes, that's the kind of result. So basically, you have the idea of the image, the accuracy of the result, the loss, and the level of the given image. Is it 0? Is it 4? Is it 1? Is it 9? So this testing the image with this ID is, well, you can say 100% that it's 9. So I encourage you to have a look if you want to test that yourself, and if you want to struggle with AWS SSH login. I encourage you to have a look at the Yahoo, Kafka and Spark project on GitHub, and SparkNet project. They are both doing the same thing. And if you want to go deeper in the theory, you can have a look at the SparkNet paper here, and see and understand how they come up with this implementation. This kind of broadcasting the model and updating gradients and
The largest image, the largest instance,
yes.
How long it takes to train them?
With the MNIST,
Okay.
takes about 5 minutes. Yeah.
And which subsample do you use? Or
Which
the
data?
Yes, of the image. Subsample of the pixels?
Yes.
How?
We take like small test picture.
Yeah, but how small? Very small. It's
What's the size?
Yes.
I think it's 25 by 25. Let me check. Well, I can then download it and see. It's from. If you want to get it, you can get it from Jan Lecoul's website. It's one of his data sets.
It's already prepared.
Yes, it's already set up. This is a data set that is already prepared for computation. Same with CIFAR. CIFAR 10. It's also 10 categories of image that are already prepared. So you can try to train a deep learning network with that and see what it does and how it works. It's a really good way to start to experiment and to play with deep learning. And then after that, you can build your own model. But building your own model may take a bit longer. You need lot of images, and you need a lot of images to train it and then to test it. So you need to split the image between test and train mode. Yeah.
There is no questions.
So
There's some questions.
Yeah.
Just one question. Which is the difference between Spark Net and Kafka Spark?
It's really slight difference. They are not much different, but the same. One is maintained by Berkeley scientists, and the other is developed by engineers. But they do the same thing, and there is the same computation. So it's mostly the same. I would opt for the one that's the more active, but they are both active at the moment because they are quite new. SparkNet came up 2 months ago, and Kafka and Spark like 1 month ago, so it's mostly the same. But I mentioned both because they both exist. So I encourage you to experiment with both because they are both as good. And maybe if you don't understand something on one, just try to see on the other one if you can understand it. But I would say SparkNet is more academic oriented, more simple, more hacky, and Kafka and Spark is more industry. It's more developer focused. I don't know. Well, it's my personal opinion. I think they are both good.
There's no any question. Let's want to join us downstairs.